Hi everyone. In this video we'll be covering a rather basic problem of thermodynamics. So in the question we are given a PV curve and a thermodynamic process A to B, and we have to find the maximum temperature attained by the gas, by the n moles of gas in this particular process. So there are several ways in which this problem can be approached, but the most fascinating and the fastest one will be mathematically. So what we'll be doing is we'll be writing the equation for this curve, for this linear curve A to B, and extracting it in terms of temperature. We'll have a function and we'll just maximize that function. So now for the very first step, we know that the general equation for a linear curve is y minus y1 is equals to m times x minus x1, where m is the slope for the curve. For in this case, we know that the slope is going to be del y by del x is minus p naught over v naught. It is a decreasing function. The final equation in terms of pressure and volume comes out to be p is equals to minus p naught by v naught times v plus 3p naught. Right. This is the final equation for the curve. Now for the second step, we'll be extracting this in terms of temperature. Temperature is PV by nR, where n is the number of moles of the gas. It is going to be 1 over nR times 3p naught minus p naught over v naught v times v. Since finally we have a function of the temperature and volume, right, what we'll be doing is we'll be maximizing this function, or we'll be finding the volume at which the temperature is maximum, right? So we'll be doing dt over dv has to be 0 to find the critical points of this new curve, right? So once we're onto this derivative part, 3p naught by nr minus 2p naught over n r v naught. So the volume at which the derivative is 0 is 3v naught over 2. Now we have the volume at which the temperature is maximum. In order to find the maximum temperature, we'll be plugging in this value in this temperature volume function, and then we'll have the answer as T max is equals to P naught V naught over N R times 9 by 4, right? And that was it, people. Thank you.